Welcome to everyone. Yeah, thanks a lot for joining the webinar from Legacy to Cloud Native, which is organized by Kubermatic and Portworks. And we are here today with Mario Falan from Kubermatic and with Daniel Paul from Portworks. As for some organization aspects, we are recording this session and we are going to share the recordings with you afterwards, and also the slides, also with the people who couldn't join today, so they can also see it. And also, as I already said, there's the Q&A enabled. So once the presentation is over, you can use the Q&A to just ask any questions and they will be responded. And I would say that's all. Enjoy, get a lot of new insights, and thanks a lot for being with us. Mario, the stage is yours.
Yes, hello and welcome everyone on this beautiful Thursday in May. I'm here with Daniel from Portworks. Daniel, why don't you introduce yourself?
Yeah, thank you. Yeah, thanks for joining. So I'm Daniel Paul. I'm a cloud native architect at Portworks. So I'm covering all technical aspects on our data platform for Kubernetes. And I joined Portworks nearly 2 years ago. Previous, I've been with VMware doing network and security, also in the container stuff. And yeah, happy to be here today.
Yes, and short introduction to myself. Hi, I'm Mario. I am a customer delivery architect for Kubermatic and the technical lead for the Kubernetes SIG contributor communication subgroup. I am with Kubermatic since, I think, 3 and something years, and I'm basically mostly involved in customer projects and customer work and also developer relations. So why we are here? The reason why we're here is when we all heard this, yeah, we are all cloud native and we are all using cloud, and we are getting into the point where we have the problem that when we look at cloud adoption, it's growing, of course, but let's be honest, a lot of companies are lacking a little bit behind because it's like, why change a running system? So we still have a ton of workload in every environment that is still running on VMs. And usually when it comes to enterprise IT, it's like, we ignore the stuff. And at some point we get to the point, oh, fuck. And as some things happened in the past, a lot of companies got to the point that they are basically vendor locked, and we want to look now into the cloud native way of how we can still manage our VM workload that is still present. And why does this happen? I mean, the problem is for a lot of companies, IT is not their main business, and it shouldn't be their main business. It's just like, we need to take care of IT because it's part of our industry. So it's also, IT is a reliability. So we need to have talents. We need to have an eye on the emerging, what is the new technology. And let's be honest, the cloud native world is moving super fast. I mean, even engineers or Kubernetes members and contributors can't keep up with. I think we are at 185 or 186 official CNCF projects. So it's really hard to keep up with all of this. And we still have to maintain day-by-day work. And we need to change our resource distribution in this world, because we have only so much resources, which is time, material, and people that we can throw at tasks. And a lot of time is going into maintaining our portfolio, but this also leaves us with the legacy gap and with the problem that we cannot advance our technology and we cannot adapt to future changes. So when we go into the history of virtualization, it's longer than a lot of people might know. And I mean, virtualization is still being used a ton in different companies. And we can basically go back into the 60s, where the first concept of virtualization arrived in mainframe systems to use maximum resource utilization. And the funny thing is, this is a reoccurring topic, because when we look at Kubernetes itself, it's also utilization of the machines. And when we look into VMs, it's like, yeah, we have a ton of VMs that are just idling and doing nothing. When we go a little bit further, 1970s to 1990s, not much happened. But when I started working in IT, this was basically also the years where the big hypervisors started, like VMware, that basically transformed the whole market and took a huge chunk of, I want to have my workload in a virtualization so that I can basically create as many machines on platforms as easy as possible. But a lot of companies stuck with this. And we are now moving toward a cloud-native world. And cloud-native does not necessarily mean that cloud-native runs in a public cloud provider. Cloud-native can also mean that I use a cloud-native stack in my own data center, and I want to use the benefits of cloud-native in my own data center. And the time it took for virtualization to get to this point really was it's expanding more and more, and we need to basically have a look into what is the newest stuff and how I can reduce the overhead. So when we go back to the idea that we only have so much people, we need to have our virtualization in the same way as we have, for example, our Kubernetes clusters. And the good thing for this is, and this is basically where we are now, is that you can do Kubernetes virtualization as part of Kubernetes itself. So it's not another stack that comes on top of it. We use a technology that we already have to use, because a lot of workload is running in containers and we need a container platform and so on and so on. We can now do the same for our legacy workload that either we cannot move, that is too expensive to move, or that is just not in a state to be moved out of a VM, and run it side by side in a Kubernetes environment. And for this, we are looking today at something which is called KubeVirt. And KubeVirt is basically the open source solution for virtualization in Kubernetes. So our stack that we want to look at today is virtual machines. We have them, they are lying somewhere. We have images lying somewhere, or VMIs lying somewhere that need to run somewhere. We have our Kubernetes cluster that we already have in our environment. And we also have, as a new part, KubeVirt. And for KubeVirt, because we still have VMs and we know that VMs are stateful, and we get in depth into this later, we need storage. And storage for VMs is more critical than for usual container workloads. So we need to have a really, really deep dive into what are the benefits of a solid storage provider that we can have to run our machines. Because for Kubernetes itself, the main requirement is, the storage for our etcd must not be slow, but that's the only requirement. But when we go into KubeVirt, this expands a lot. So why KubeVirt? So we already talked about basically the benefit of having a unified platform, because when I need to take care about my workloads, I can basically use the same environment that I already have for my containers. So it simplifies the management of the different workloads that I have and that I need to run. So I can reuse my already in place workflows. I can already reuse my CI/CD pipelines. I can reuse the expertise that the team already have, because KubeVirt itself is a Kubernetes native project. So it speaks the same language. It follows the same paradigmas of declarative style. So everything is basically found and declarated in our environment. I can use the advantage that we have to scale naturally. So it is easier to just create new VMs in an automated way, because we use the auto scaling, for example, for Kubernetes itself. If we go on-prem and if we go on bare metal, that's a different topic. but even there are ways to basically more or less auto-provision machines with also open source tools like Tinkerbell or something that goes into the same direction. The good thing is also that we have a workload flexibility, so it doesn't matter anymore what is running in our environment. It's like there's a container that runs there. There's also a VM that runs there. And more importantly, there might be a Windows VM that is running inside of my container workload, and it's treated more or less the same way. So we have the operational efficiency with we can leverage also the knowledge that our SRE team has for, oh no, something is wrong with the VM. If something is wrong with the VM, it's something that is wrong within a pod that is running inside of a Kubernetes cluster. So we can basically debug the pod. We also can utilize the self-healing aspect of Kubernetes, like it's retrying every time to recreate all of the different things if it fails. And we also have the benefit of an isolation that comes within Kubernetes itself. So we can put VMs into different namespaces. We can apply network policies to specific VMs that run inside of a Kubernetes cluster. I can also restrict access. We can add policies to the different parts. So I can utilize the whole cloud native stack that I have as a benefit to use inside of the Kubernetes world. How does this look like? In the end, it's like we install KubeVirt on a Kubernetes cluster, and you have your different worker nodes. On the different worker nodes, the agent is running. We also have a controller and an API. We will get to this in a minute. And then we have like containers running on the different workers. We have VMs running on the different workers, and we can also move things around. And that's the real cool thing. So if, for example, a node breaks below this, given the storage is able to handle this, we can basically move workload is being auto rescheduled to the different parts. So we can basically use those really, really cool self-healing aspects and to have a zero downtime environment for our VM world. When we come to the architecture, we have different parts of KubeVirt that are interesting for us. So we have a scheduler that is there to watch the VMI. We have to schedule the VMs. We have the Virt handler that is mainly watching changes in our virtual machines. And we have the virtualization layer with libvirt that is handling the virtualization. We have the operational flow to create VMs, to start them, to run them through their life cycle. There's a shell that we can access, that we can utilize. And this is basically just a quick overview of how all of those components run together and where they are. And the good thing is, for all of these commands that we use and that we utilize, we use something that every Kubernetes administrator already knows: kubectl. Because everything is using the API server of Kubernetes itself, and we just expanded with the Virt controller and the Virt API to really handle what is going on inside of the environment. The funny thing is, I just found an error in the slide because we don't have Docker anymore. We have containerd, obviously. So how does this look like when we look into it in a practical approach? So let me quickly stop sharing this screen and let's go into my shell. I hope it is visible, and I will basically go ahead and say like, I'm sorry. So this is how a virtual machine looks like in Kubernetes that we can create. So the good thing is, as you can see, it's the same style as you would create a deployment. It's the same style as you would create an environment. And you basically, the only thing that it's needing is like, where do I want, how big should it be? How should the sizing be? How much memory it should use? How much CPU it should use? What disks I want to have. And for this example, I have basically no stable disks because it's just an example. And what I want to do is I can just apply this to the cluster. So I can basically say like kubectl apply -f, and then say VM YAML. And it tells me it didn't change anything, but I can now go ahead and say, it's already, I want to start the VM, and Virtualization is basically the command line tool to interact with your virtual machines inside of your cluster. Yeah, of course, you can get like add a volume. I can get I upload an image. I can migrate the machine. I can port forward stuff so that I can connect to the machine. I can do like a soft reboot and so on and so on. Everything that you would do in any other virtual machine handling. And you also can basically see if I do a kubectl get VMs -a, I get the state of my VM, and that is running. However, as we said in the beginning, the main problem that we have is we need storage for this because a VM without storage is useless. And a VM without storage and the requirements that we have for those is basically, we need persistent volumes, persistent storage. We need performance because it needs to be fast. We need to have disaster recovery and data management. And for this, Daniel will tell you more how you solve this problem.
Yeah, thanks, Mario. Could you stop sharing so I can jump in with the part? Okay. So yeah, when it comes to VMs on Kubernetes, it's all about the storage. Storage gets more important. But let's first go into the first steps of a containerization journey of a typical customer. So usually when customers start with Kubernetes, they are starting stateless. So this means they deploy the first Kubernetes clusters and no data will reside inside the Kubernetes cluster. All the containerized applications will be stateless. In our perspective, this means they get information from somewhere outside, process these information, and then send the information out of the cluster. So there will be no data persistence within the cluster. This is usually the state where people learn how Kubernetes is working. They adopt the processes, get an understanding of how everything works. And on the typical journey, we then see the first demands of developers or teams asking for having persistent storage within the cluster. And this is usually smaller databases, which are part of a microservice application, which is newly created or being tested on the platform. And this is the point where most people start going into stateful applications in Kubernetes. This means they try to figure out how to get storage into the cluster. And each and every platform, each and every cloud offers something which might be good enough to fulfill those needs. So people start with this. Usually they have no SLA on the storage at this time. And developers start deploying these databases and doing tests with the applications. So everything's running fine. But then at a certain point, they get into a more, let's say, critical state because these applications are now getting business critical. So these applications are already developed, they are going into production. And at this point, we call them critical stateful applications. This could be modern apps or legacy apps. And at this point, usually other people start asking questions. It's things like, is this data high available? How does our disaster recovery strategy look like for this data? How are we handling backup and restore and all these things? which might be clear in the classical IT environment, but they are at this point usually not solved within the containerized environment. And this is the point where Portworx comes into play, because we see more and more customers bringing business critical workloads onto Kubernetes. And if you also follow the statements from IDC or Gartner, you will see that Kubernetes is currently enterprise ready. More and more enterprise applications are going to this, but we also see that many organizations fail if they don't have a proper data strategy on Kubernetes. And this is where we come into the game and where we can help. And especially when it comes to virtualization on Kubernetes, this is a critical point, because you usually cannot run a VM stateless. So what we are offering as Portworx is a data platform which covers all these topics related to storage. And I will go deeper into this in the architecture and in the why you should do this. But on a high level, we have a storage platform which is container native, running in Kubernetes, is built for scale, it's built for stability, and it's also built to abstract whatever your platform delivers on storage. So with Portworx, storage looks the same regardless of where you run your Kubernetes cluster, on which distributions you're running your Kubernetes cluster. And we also offer capabilities to have the possibility to migrate data between different Kubernetes clusters and between different platforms. So I will cover all these points in detail at the next slide. But one more important point is also backup and recovery, because you need to have a solution to run backup and recovery for containerized applications. Just backing up and snapshotting worker node VMs doesn't make any sense. You need a backup solution which is capable of containerization, capable of Kubernetes. And last but not least, if you have a very stable platform providing stateful storage to Kubernetes, we often see then issues with developers spinning up lots of databases, lots of different data services on different clusters, which often raises the demand to have a, let's say, single point of control for all these data services, to give developers the capability to deploy these data services very fast in the different environments a customer might have. And also having the platform teams take a look on what's running in the clusters. And this is our data services offering, which means we have a control plane to deploy data services within your Kubernetes clusters. And these then are backed by Portworks Storage as a stable storage layer. And as I already mentioned, all these products have many things in common. So we are independent from the underlying cloud. We don't care if you're running in the public cloud or if you're running in an on-prem environment. Even you can run on bare metal if you want. We're also agnostic to the underlying infrastructure. We don't care about the compute and the storage hardware underneath. We abstract whatever we get, and we provide a unified layer to the Kubernetes users wherever you are. And we support each and every Kubernetes distribution. So we have active support for all major distributions. And what customers usually do is deploying stateful data, databases, data services, streaming workloads on top of these platforms. So when we dig a little deeper into how Portworx actually works, it's a Kubernetes native solution. So we perfectly align into whatever Kubernetes is doing. So we are controlled by an operator, we are configured by YAML specs, so we can integrate into any automation which is focused on Kubernetes. And Portworx itself deploys into a Kubernetes cluster and resides there. We create some custom resources within the cluster which help you to interact with Portworx and all its functionalities. But basically, we are perfectly aligning into the default way of operating Kubernetes. So technically spoken, we act as a provisioner for storage classes in Kubernetes. So if someone today knows how to claim storage within Kubernetes, it's basically the same if you're using Portworx. Our basic design principle is that we take block storage from the Kubernetes worker nodes and bring this into a pool. And this pool is our layer of abstraction. And out of this pool, users can claim volumes. So they can create persistent volumes, which are being provided by Portworx. These volumes can be read-write once, read-write many out of the box. But again, the basic design principle is unused block storage is taken from at least a certain amount of worker nodes of the cluster and brought into an abstraction layer. And now when we come to these non-used block storage on worker nodes, if you're running on an let's say on a cloud or on an infrastructure layer, which offers more ways of automation, we can integrate into this. So we have an orchestration layer, which integrates into AWS, Azure, Google, or vSphere, where we can fulfill the need of block storage on worker nodes in an automated way. This means if you're running, for example, on AWS, you can tell Portworx, hey, I want to have each worker node contributing 1 GB of storage to the pool. And then Portworx would go and connect to the AWS API and would attach 1 GB of storage to each of your worker nodes running in AWS. And at the point Portworx is up and running, the storage layer would be ready to consume. So we can improve the speed of creating or provisioning storage within Kubernetes by automating this stuff, by standardizing this stuff. This takes out risk and improves flexibility, and it improves also time to market. So this is basically how we work on a high level. And now I would go into why you should do this. What's the benefit for you to implement this layer of storage in between? And first of all, we can provide multiple storage classes. So whatever your workloads need, we can provide it. So you can have block and file storage for your workloads. We can offer different levels of performance. This means whatever a worker node gives us as a backend storage, we will benchmark this, and you can then refer to this type or quality of storage within a storage class. So you can say, I want to have my data being stored on slower disks, on medium speed disk, or on high speed disks, which technically usually relies to different type of cost in the public cloud, for example. And we can also offer different layers of protection, because if we rely on a Kubernetes worker node, this also means by default in Kubernetes, everything can fail at any time. So we can lose a worker node at any point of time. We can even lose a complete availability zone in Kubernetes at any time. So we need to have an answer on this. And Portworx can do this by creating a protection level, by creating redundancy over the worker nodes. So if you have a multi-AZ Kubernetes cluster, you can lose an AZ at any point of time without the loss of any of your production data. And this also applies to worker nodes. So you can lose worker nodes within your cluster without losing actually access to the data. When we take a look into the applications, and containers are just one kind of applications, we now see, as Mario already mentioned, also VMs running on Kubernetes. We can work application consistent. This means if you want to snapshot, for example, a containerized MySQL database, you need first to find out all replicas running of this MySQL database within your cluster. Tell them to empty caches, log tables, and then you need to take a snapshot of all volumes being claimed by this application. And then you might also notice the application to continue normal operation. And all this is solved in Portworx in a Kubernetes native way. So you create a YAML spec which describes which steps are being taken, and then you can apply this to your normal GitHub pipeline if you want, or to Argo, and then automate this in all your clusters, independent from the underlying infrastructure, independent from the Kubernetes distribution itself. So this is just abstracted, automated, standardized. We can also cover encryption in the cluster. So you can ensure that Portworx encrypts all your data, which is then encrypted at rest when it lands on the backend storage of the worker nodes. This is all being managed within Kubernetes. So you can rely to Kubernetes secrets or to a key management system, but you can manage all this in Kubernetes ways. So you can create storage classes which create encrypted backend storage. And last but not least, we are also able to replicate data between different instances. And I will focus on this at a later point, because I think this is also an important thing to improve reliability of a virtualized environment. But with Portworx as an abstraction layer for storage, we are now able to replicate data between different Kubernetes clusters. And there is no limit when it comes to the platform or to the underlying infrastructure or even to the Kubernetes distribution. Our customers are using this to implement disaster recovery for their data on Kubernetes. So with Portworx, you can asynchronously or synchronously replicate your data being stored in the Kubernetes cluster into another Kubernetes cluster, which helps you in the case of a failure of your data center or of a public cloud region to fail over to the other region and continue your business critical applications. So there is, as I said, no limit if it's on cloud or on-prem, and there's also no limits on the distribution. There are some prerequisites to fulfill, but the most important one is Portworx needs to be running in both of those clusters. And we use also the same technology we are leveraging for disaster recovery for migration. So with Portworx, you're now able to migrate your applications from one Kubernetes cluster to another one. Well, that's an easy thing for just, let's say, containerized applications, because they are usually described in a YAML spec, and you can apply this YAML spec to another cluster, and then it's there. But it gets more complicated when the state comes into the play, because you cannot just create a new persistent volume on another cluster, because this would be empty and you would not have your data in this volume. So Portworx offers capability to migrate data on a namespace level between different clusters, and this is our migration feature. And this helps customer, for example, to migrate applications from an on-premise environment into the public cloud, or also migrate between different public clouds or different public cloud regions. So now you have the capability of data portability within your Kubernetes clusters, additionally to disaster recovery, backup recovery, and all these pieces. So on a high level, how does this look like? And this is working for containerized applications as well as for virtualized environments, so for virtual machines. So we don't make a difference if this here is now a container or if this is a VM. We need to have two clusters. One of the clusters is running a production workload, and we can now link these two clusters to implement an asynchronous disaster recovery or migration. So on the Kubernetes layer, we create a cluster pair, which means cluster 1 gets an information how to reach cluster 2. The second step which needs to be taken is if you want to do async DR, you need to define a time schedule, how often this async DR should happen. And at the third point, you can define on a namespace level what to migrate. And this means you can say, okay, my users are now able to migrate their own namespaces between these two clusters. This is all, again, YAML specs. So you create them once, apply them into your repositories, and can automate all these pieces. And now what Portworx would do, it would now start snapshotting the production site and migrate it using an object storage in between into the second cluster. So here in this example, we have a Postgres, a MongoDB, and a MySQL running in the first cluster. This is now being snapshotted. So we take all the Kubernetes objects, but we also take snapshots of the volumes, and we ship them using the object store into the second cluster, and we create them in the second cluster. This means if we would now take a look into the second cluster, you would see that there are all the volumes, all the PVCs, all the Kubernetes objects. The only difference is by default, if it's async DR, we do not scale up the applications on the second site. They are just there, but you would see them, but they would not run. And in case of a failure of the first cluster, there's a single command on the second site where you can just spin up your applications. And again, there's no difference if this is VMs or if this is containers. We can do it for both. So now let's take a high level, and Mario already mentioned that technically it's not a big difference between VMs running on Kubernetes and containers running on Kubernetes. Both is just a process which is limited by namespaces and C groups, technically speaking. And from the Portworx perspective, both are containing or both are consuming PVCs. So on a container, we say it's basically a PVC which is consumed by the containerized process running in the pod. And if we run a VM, it's technically the boot drive or the disk drive being attached to the VM, which is on a Kubernetes layer just another PVC which is attached to a process running in a containerized environment. So from a low-level technical perspective, it's no difference if you're running VMs or containers on Kubernetes. There are some differences where we take a look into our implementations, but basically, yeah, it's not a big thing. So quickly summarized, what's the benefits of running Portworx together with Kubermatic for VMs and containers? It's a common layer for storage applications, containers, and VMs. We have a heavy focus on performance. We have high availability within the cluster. So as I said, if we lose a worker node or an availability zone, we don't care because we have a replication inside the cluster running. But also in case of a cluster failure, we have capabilities for backup and restore and disaster recoveries. And both are treating VMs and containers the same. It's not a difference. And we also support the live migration of VMs within the environment, because this is one of the killer features customers always demand when they put VMs onto a Kubernetes environment. They want to be able to migrate VMs between different nodes to maintain availability of the application inside the VM. So with Portworx, with Kubermatic, you have the choice if you want to run on-prem, in the public cloud, on a hybrid cloud, or even on edge environments. It's always the same platform. It's always the same way of management. So this takes out risk. This improves efficiency. And yeah, as I said, you need to work on a proper data strategy for Kubernetes if you want to go into the enterprise space there, and especially when VMs come into play, because usually customers don't run VMs stateless. So I would now hand over to Mario. Will you just take the screen?
All right. Yeah, thanks, Daniel. And I think one of the most important sentences from my personal opinion in there is that we have to take in that we want our workload ready for live migration and stuff like this. But the problem that we also face is like, yeah, it's nice that you now can use Kubernetes with virtualization and stuff like this. But the problem is we are facing also the issue with the whole underlying layer. I mean, yeah, we discussed about it that the underlying layer is either taken care of by public cloud providers or so on and so on. But when you go down into your own data center and you are currently stuck with a single provider, you're also facing the problem with the whole network architecture that needs to be built up and needs to be replaced. And the good thing is that there are ways to work around this. They are then not as straightforward as just installing KubeVirt in a cluster, because then you need to dig into KubeOVN, which is also an open source tool for creating networks and creating network environments in Kubernetes. But there are alternatives in the open source world to utilize the different ideas and also to replace stuff. We at Kubernetes thought that this is all very interesting and this is all really, really great, but let's be honest, a lot of companies and a lot of folks don't have the time to deal with the stuff. So basically, we implemented KubeVirt into as a first-class citizen into our Kubernetes platform, so that you can basically use KubeVirt out of the box. And the cool thing is you can run nested KubeVirt, which does not necessarily always make sense, but in some use cases it might make sense. So the idea of Kubernetes is we run Kubernetes clusters inside of Kubernetes clusters, so that you save your control plane. So the control plane is only running on worker nodes, and this can already run on a KubeVirt cluster. So you can basically create then those worker nodes on those KubeVirt clusters. And when we can basically extend this, there are two different ways what we can do now. We can either directly have in the management cluster classical VMs that are in our management state, or we can also just run KubeVirt inside of the worker clusters, so that we can have like not a noisy neighbor problem, so that teams can deploy into their own clusters their VMs, and they are not affected by hiccups that are caused by other teams. So we can basically use those KubeVirt virtualizations there as well. And the good thing is KubeVirt also supports anything regarding AI workloads. So we have GPU pass-through, so that we can use GPUs and TPUs. We have ARM support, so we can basically also run in ARM environments, and the ARM world is ever more expanding with also like the big cloud providers buying more and more or getting their own ARM license, like Google did or AWS did last year, and providing their data centers with ARM. So KubeVirt is also safe for if you want to go into this direction. And this is also a topic when we go into edge. If you have like small edge devices that are based on ARM or on shuttle PCs, you can virtualize those as well. So we have basically an all-in-one solution, and we don't want to take care of this. So basically how this looks like, if I do it in Kubermatic, and I already prepared something. So when we create a new cluster, I can basically go ahead and say like, I choose wherever I want to run. So I choose my environment, I choose it's either edge, it's a KubeVirt cluster itself, it's an OpenStack cluster, it's a vSphere cluster, whatever I want to use. So let's go for KubeVirt. I select my data center. I basically select which CNI I want to use. And then I say like, yeah, this is the credentials that I want to use. And then I can say like, hey, which instance type do I want? So I can even have instance types predefined that I want to use in my environment. Or I just say like, I want to have a machine with 6 CPUs and 8 gig of memory. And then I just select like which image do I want to use, so which operating system image I want to use, which storage class should be added to the worker node, and then, and this is the cool thing there, I can basically select KubeVirt out of the application catalog and add it to my cluster. And when I create now the cluster, it will start the containerized control plane on the seed, and then will create eventually the machine. And how this looks like, and let's take this one. We then have our cluster running, and we have in our applications KubeVirt. And if I go into my shell, and I do basically kubectl get all pods, I see that it's installing and applying already the installation for KubeVirt. So I don't have to take care of having KubeVirt installed in my cluster, because Kubernetes itself is taking care of this via the application. And I can still modify it, because I can still change values and different settings in there. And with this, we are basically at an end. Thanks for joining. Are there any questions? There's a FAQ button on the bottom, and you can go in there and enter the questions, and then we can see them.
So no questions so far. When taking a look at this from my VMware perspective, from a former perspective, there is also a lot of UI integration in your platform, Mario, right?
Yes, it's basically everything you do in the UI, but we also have the possibility that you have we have the possibility to basically do everything via CI/CD. So you can basically do this also in the declarative style in Kubernetes itself. So any topic is part of this. We didn't have a question. There's one question now. I'm not seeing a lot about the VM integration, only the KubeVirt is installed, but can you show more about how such a VM is created and how does it function? So this is basically what I showed in the beginning. The VM is the thing that I showed. Give me a second to share my screen.
Yeah, while you're sharing, so one important thing is you have the UI, but the UI just creates declarative, let's say, YAML specs in the background. And this is a huge difference to let's say classical VM environments, where you have a UI which is which hides all the complexity. But here, Kubernetes basically is working in a declarative way. You create YAML specs, and the UI is just, let's say, hiding this. So you still create YAML specs in the back end, which could go into automated pipelines and all this stuff. So you can leverage this even if you're working on a UI level here in the first steps.
Yeah. And the idea is that your VMs don't reside anymore in this. I have them in a UI. I have my VMs as every single piece of infrastructure should be reside in a stateful way, like a repository or something like this, so that they can always recreate it in an automated way. So the virtual VM creation is basically I apply this VM spec into the cluster, and then I say start the VM, and then the VM is running, and that's it. And there's also an automated tool where you can take VMI images and import them into KubeVirt, and then they are running. Then they are using the VMI image because they are putting them into a persistent storage. I hope this answered.
Yeah. So Mario, while you're looking at your screen, let me quickly read some questions we already got. So the first one of the questions is, can you host Windows VMs? And I can answer this: yes. Windows VMs are fully supported in KubeVirt, so you can migrate your Windows VMs into KubeVirt. That's not a problem. There's also the question: can you access the VMs from the management interface of Kubermatic? So do we have a
Not yet, but this will be a feature that is coming in the upcoming releases.
Yeah. So currently RDP, for example, for Windows VMs would be the way to get into the VM.
Yeah.
There's also on the virtctl command, there's also a way to access VMs.
And port forward it, so you can basically port forward. It behaves the same way like a pod. So you can basically port forward it and access it this way. And actually, you can access it in the UI because we have a web shell included. So we have a web shell, so you can basically use the web shell to get into this. Yeah.
Okay, and you're working on a way also to get Windows VMs into the UI, so
yeah,
like a VNC or stuff like this within the UI. Yeah. Okay.
And I mean, the thing with also the benefit is you can over provision in KubeVirt. So KubeVirt has the ability to over provision, which means that, for example, if I have a node with 10 CPUs, I can create VMs that are more than 10 CPUs, which is like good if you just know that certain VMs won't go over a limit or have from a scheduling perspective. So you would fully use your environment, so the hardware that you have at hand.
Yeah. So maybe just as a quick summary from my side. So I see a really sweet spot for this solution if you're already in a containerized environment. So if you're already working with Kubernetes and containers, this is a small step to enable these capabilities within your clusters. And the benefit here would be you might already have applications being partly containerized. So meaning the application layer is running in a containerized application managed by Kubernetes, but you still have VMs providing databases, for example. This is a typical example we see often in customer environments. And it's really smart to move now these VMs onto Kubernetes because you now have a single, let's say a single pane of glass to look at the full application. So meaning the database belonging to the application inside a VM and also the containerized parts. And maybe at a later stage, you could think of ripping out the database of the VM and just running it natively on Kubernetes. But you can do this whenever it fits into your resources, into your schedules. So this is a real sweet spot of hosting VMs on Kubernetes, having the same management, having the same, let's say, tool set, and having the same responsibilities for the whole application and not handling with different platforms, trying to find out where's the problem in between those two platforms. So this is a real big thing. So I also see comments in the Q&A about this is massive and this is a huge change. So yes, this is something, but I think it's worth taking a look at it because containerization and Kubernetes is here to stay. I don't expect it to go away in the next years. And you could leverage this when bringing also virtualization into this platform. If you want to have more information, one last sentence from Maya, then Mario, you can finish. If you want to have more information, if you want to have more, let's say, focused information, more technical, more high level, more decision maker ready, just give us feedback. We can set up another call and focus directly on this. Today, we've had the challenge to get everything, giving you the idea, what's behind it, but also give some technical insights because we are all both working on the technical level. But yeah, from my side, thanks for joining, and last words to Mario.
Yeah, we still have some questions. I will quickly rush a little bit through them. So does it make sense to use KubeVirt at a bare metal on-prem cluster? Here is also a virtualization environment like VMware to host the worker nodes. That's exactly what we do. So the cluster that I created is basically this. So we created, we have a bare metal cluster. We have KubeVirt running on it as a virtualization layer, and whenever new nodes are created for the Kubernetes cluster, because we have something that is called machine controller that is taking care of machine creation, machine lifecycle, updating machines, removing machines, and stuff like this. And this is basically then spawning the machines. So this is highly recommended that you basically use KubeVirt as your hypervisor for even this. Any support for NUMA VMs on KubeVirt? The funny thing is, yes, there is, but it's limited to the use case. You always have to keep in mind that it's an open source project, so the people are looking for feedback, and this is something that goes into. It's a general topic that people need to understand that. If something goes GA in Kubernetes, it's hard to change. The same thing goes now for KubeVirt. So I highly recommend to use alpha and beta features of Kubernetes and KubeVirt and give feedback, because there you can make an impact. This is what the community is looking for, and this is what we are always asking from the Kubernetes perspective. If you, for example, have a specific use case that is not yet supported in NUMA, go ahead and raise the questions. There is in the user guide, there is in the documentation of KubeVirt, there is basically a single page dedicated to NUMA and what the capabilities are. So the next question was, do I need to create VMs from scratch, or can I also import existing VMs? Yes, you can import existing VMs. You can basically use anything that, for example, you can use in VMware. You can basically export them and import them into KubeVirt. If I have maybe around 800 VMs, maybe in a vSphere environment, does it make sense to migrate them to KubeVirt, or is KubeVirt more used in a way when I only want to start running VMs and will use it only around 20? So the idea is basically, this depends. And this is not, I would say this is not so much of a technical decision. This is a business decision. So if you are happy, for example, with pricing and support from VMware, why change? If you want to go ahead and say like, hey, we need to come up with another solution, and this is basically what we are talking about. Is it's an alternative solution that is based on an open source technology. Then I would say, if you want to save money, migrate. The good thing is it scales more or less indefinitely. I mean, this is limited by your hardware or your environment, how this is scaling. Because Kubernetes itself, I mean, there is a theoretical limit when it comes to nodes. There is the official supported amount of nodes inside of a Kubernetes cluster is 5,000. The Kubernetes community is running a test every 24 hours to see if the current Kubernetes versions are supporting 5,000 nodes. And this is basically where we say that's the amount of nodes that Kubernetes itself supports. But the good thing is you can have more clusters. So if I would have to have more hardware nodes, and we are then talking about hardware clusters with hardware nodes, right, as underlying layer. If you go over 5,000 nodes a cluster, just add another cluster. All right, with this, I think we went through all of the questions. If there are any more questions, please feel free to ping us, and let me quickly share just our contact slide again. If you might have missed it. We will also share the presentation in the end with you. We will also share the recording of this talk, of this webinar with you. And Daniel creates way nicer slides than me because they are fancy animated. So if you have any questions, just ping us, reach us under email or on any social media channel. We are happy to jump in a call with you to discuss things more deeply. Thanks for joining. Thanks for your attention. And I hope we could give you a little bit of insight and some new ideas how to move into a cloud native VM future, which sounds really bad.
And yes, thanks a lot from Portworks and from Kubermatic. And I don't know if you want to say something else, Daniel, but if not, I would say thanks a lot for joining. And as Mario said, exactly, you will receive everything and you can contact us anytime. So I wish you all a good day and bye.
Bye, folks.